Okay, folks, we're almost there. Let's talk a little bit about factorial ANOVAs. So remember from the first lecture video of this series that we had to determine something as factorial when we had at least two independent variables. This is different from the one-way ANOVAs we talked about in the previous set of videos because those are only applicable when we have one independent variable. So whenever you hear the word factorial, two-way, three-way, independent group, repeated measures, ANOVA, the first question we need to think about is when you hear the word factorial, automatically assume there's at least two or more independent grouping variables in this kind of research session. Okay. The other thing that we need to think about is this a two-way independent groups factorial ANOVA? Is it a two-way repeated measures factorial ANOVA? Or is it a mixed factorial ANOVA where one of the independent variables is independent groups and the other independent variable is repeated measures? And so we have some things that we need to think about, but really what we're doing is taking this more complex design and we're building something that's more complex based off of some of the basic foundational principles we know about one-way ANOVAs for independent groups and repeated measures that we learned thus far in this video. So what is a two-way repeated measures ANOVA then? So in this particular case, again, two-way means I have two independent variables. Repeated measures means that both independent variables are repeated measures or repeated condition independent variables. This can be expanded to three-way ANOVAs, four-way ANOVAs, and all kinds of ANOVAs that are raised to a factor higher than that. So the key is that whenever you see that word repeated, it means that the same participants are receiving all conditions. This is exactly the same as a one-way repeated measures ANOVA. This is exactly the same principles as a paired sample t-test. Okay, so we need to know that. So when we talk about mixed factorial ANOVAs, we're talking about two or more independent variables, and one or more of the independent variables is independent groups, and one or more of the variables is repeated measures. What is the real benefit of using these factorial designs is really the interaction piece, right? And so when we do a one-way independent groups or repeated measures ANOVA, it only tells us information about the data for one variable in that sample from a larger population. What the factorial ANOVAs really do for us is they help us to determine how data from one subgroup and another subgroup interact with each other, such that do older participants who perform aerobic exercise, do they have different fasting blood glucose compared to younger participants who perform an isometric exercise, right? And so in other words, your age might matter in a one-way independent groups ANOVA, but what we're thinking about in a factorial and specifically a mixed factorial ANOVA is your age and the kind of exercise that you perform somehow are interacting with each other and causing a unique change in an outcome variable of interest. And so interactions are often much more interesting than looking at what we call main effects. And so whenever you hear the word main effect, just think about a regular ANOVA, right? So the main effect for a one-way independent groups ANOVA would be the main effect for the one-way independent groups ANOVA. But in factorial designs, when you have two or more independent variables, regardless of whether they're independent groups in nature or repeated measures in nature, is you have to be able to partition them too. And so you can just answer the independent groups question. That's called a main effect for factor A, or the independent groups component of the design. You can answer the main effect for factor B, which is isolating the repeated measures component and only exploring the data from the repeated measures component. And then there's the interaction, which is what happens when your group membership and the time point at which I measure it is causing there to be differential findings. So the way that a factorial ANOVA is typically partitioned schematically would be by having the sum of squares total. We still have to calculate that. And you have to partition the variance in terms of variance that is explained from the model and variance that is explained by other factors. And so then we can partition the variance from data that is collected for just the first independent variable, data that is collected for just the second independent variable, and then the combination between those two, the interaction effects. We do this with matrix algebra, which is beyond the scope of this class, but nevertheless is something I want you to know conceptually and how to interpret with SPSS and JASP. And so we'll make sure to have those videos and do some live demonstrations in class to help you with that. So let's walk through this component then, right? So here's how this might look. So when we have this particular factorial design, we have to first calculate the sum of squares total, or the variance for all participants, right? And so the pathway for this is by partitioning the variance into explained variance and unexplained variance, right? Systematic and unsystematic variance. And then within explained or systematic variance here on the left side of the screen, you can branch that out into the amount of total systematic variance that is accounted for by factor A, and the total amount of systematic variance is accounted for by factor V, and the total amount of systematic variance that is an interaction effect. So we can figure out for this total how much of it is explained by just data collected for the first independent variable, by just the second independent variable, and any type of interaction. So in this particular case, we would have two main effects: the main effect for A, the main effect for B, and then we would have one interaction effect. So I want to just hammer home in this last slide before we get into non-parametrics and make sure that you are understanding the difference between main effects and interactions. And so these are not effect size calculations at this point. We are just saying that when we have a factorial ANOVA and there's two or more independent variables, we got to be able to say, well, if you just look at the data for the first independent variable, what do you find differently in the dependent variable? And so when you isolate and sort of partition and close the data off, you get what's called a main effect for the first factor, a main effect for the second factor, and then an interaction effect. Some other ways of thinking about interactions is that these can get very, very complex when you have three or more independent variables. So for example, when you have two independent variables, regardless if it's two-way independent groups factorial, two-way repeated measures factorial, or two-way mixed factorial, you can have three-way. And let me just explain what that third variable does. You can have an interaction where the effects of the first independent variable, main effect for A, times interaction, main effect for B, A times B, is the same as B times A, right? And so when you only have two, it's simple. When you add in a third, you can have A times B, A times C, A times B times C. And so there's more complexity when it comes to understanding how these effects and subgroups really go in different directions for our data. So this can be done either the main effects, which answers the major question just like we would for a one-way independent groups or a one-way repeated measures ANOVA. When you start thinking about interactions, you're typically thinking about the factorial ANOVA with only two groups, but you can actually have three-way, four-way, five-way, eight-way, 200-way interactions if your research question had that many levels of independent variables and groups within those independent variables. So I hope that wasn't too confusing. This is an area that definitely you need practice in conceptualizing. It's not something you might necessarily fully grasp the first time you do it, but I think by talking about it, reviewing this lecture, going through your notes, and then practicing with the assignment, with enough practice, I have seen all my students fully grasp this concept, and you will too. So I hope this video is helpful. In the last section, we're going to talk about what happens when we violate basic assumptions and what our non-parametric options are in those cases. So we'll see you there.